Alright, welcome back to my channel. This is going to be another video in the series where I read books. I guess I don't have just a general series where I read books and then have um, each book. Well, okay, let me pull up the book that I'm reading here. So I'm reading it from the Amazon Kindle Cloud Reader. So if you buy a book on there, it costs a little bit less, but you have to read it in this reader here, and sometimes that can be a bit challenging. In the past, I've preferred to get like study books and stuff in paper, because like managing windows and stuff I found was more difficult than just having the book like up and reading it while using the computer and doing the examples without managing windows. I found that was nice, but now I just have a better setup. Like I have two screens, so I can have the book on one screen and the lab on the other screen. And I found this Amazon reader is actually pretty usable. You can bookmark, you can take notes, you can skip to sections of the book based on the table of contents. So this is working for me. All right, so last video I kind of added some extra information about how to use Python for the first time if you've never used it before. I explained what a virtual environment is and why to use it, and then I opened up and then I finished reading the section on Jupyter Notebooks. I don't think I got the chance to actually run that because I ran out of time this morning. That was a early morning video, rare one of those. So I'm gonna make sure I demo that. So if I open up a command prompt here, I still have the folder I made this morning called my project, and if I took a look inside, I've got the virtual environment that I created this morning. So let's activate that. Okay, so now I've got this here. So I've got all my modules. If I do a pip freeze, that's how you see which modules you have installed that you're using. So if I do a deactivate, pip freeze, you see I don't have any modules at all because I haven't installed any modules into my global environment. I've only installed modules into the virtual environment, so unless I have that activated, I won't get any modules showing up through a pip freeze. But now that I've activated it, I've got my modules back, so now I can show this example here of a Jupyter Notebook. Okay, so simple command, Jupyter Notebook, and then now when I was a young lad using computers as a kid, I'm lucky enough to have been able to some extent use a computer throughout my childhood. People, I'd say 10 years older than me, never really were able to do that. I got comfortable with lots of things on a computer that people kind of older than me might not have been. But the one big thing I think I missed as a kid that I'm kind of catching on to now and learning more and more about is things that you have running like on your local computer, but that you access through a browser. That's something I never experienced as a kid, because I don't even think they really had that technology to that sort of extent back then. So this is new for me. It's always a little bit counterintuitive to be accessing just some service I'm just running on my own computer through the browser. I still kind of believe a browser to be taking you to a place other than your computer. I've got it's always a little bit kind of I think really kind of cool for me to see this. And I kind of wish I had been exposed to this earlier, because this sort of web app development thing is really interesting. So you can see I've got a number of options. I can click new here. I can make a new notebook. I can make a text file or folder. I can take a look at what processes and notebooks are running. Don't have any running. So let's go into this notebook. Okay, so I clicked on that notebook. It opened in another tab. Now let's go to the running tab, and now I've got a notebook running. So inside a notebook, it's just a Python terminal. So if I do print hello world, and then move my cursor to the end, or see, but the thing is, it can be a little bit nicer, because this is something we noticed here. Is I hit the enter key, and it created a new line. It didn't run the code, and that can be nice, because you're just typing out, and you can reflow it, but you've got you still kind of have the advantages of using a terminal, because if you want to say, oh well, I don't know if this line is going to work, you can click off of the cell, hit run, and now you can run it perhaps more easily that way. And you can divide your code into chunks, and then have them run in those chunks. So let's do print chunk. And then not only that, you've got different kinds of cells here. So this is a code cell where we can enter Python code, but I've also got a heading cell. So this is my next section of code. That'll be the name of this heading. So let's add a cell underneath that using oh, I thought that's how I would do it. What does this do? Move. Okay, so that's to move the cell down. So how do I? Okay, so insert a cell below, and it looks like you can just click Control B or Alt B or something, capital B. But yeah, so now we've got a new cell, and we can see there is a difference between the cells. The cell, if we run it, it just labels that. We've also got Markdown, which is just for writing out text. And the one thing that I'm remembering that, from my prior experience using this, which is limited, but is Shift Enter is how you can get a cell to run without having to use your mouse to click away from it. So yeah, this hopefully this is kind of self-explanatory. The need for this. Let's say you have a comment you want to make on your code, but where you were using a Notepad++ or Visual Studio, and you could only make a comment, there. Now you can make you can upload a picture as a comment. You can put in a screenshot for a comment. You can so you have now Markdown to make a comment, and and not only that, it is more. You can click. I thought you could do that. I can't remember. I thought you could do that. So what I'm thinking you can do, which is something that clearly would be useful, is you can easily just take out all the comments, and just have the code cells. None. Oh, I like having the line numbers in there. Oh, but it's all line 1. I don't understand that. Okay, I thought you could. I thought there was an extra setting here that it looks like there isn't. But hopefully this is clear enough, kind of why this is valuable. You can have your outputs. So like if you're using a graphing tool, normally you'd have to your output would have to pop up in a new window, something like that. I've got a juggling tool that I've been working on my other channel, that I'll show a little bit here. So yeah, this tool I worked on, you can see at the end it gives you a graph. So if you just wait at the end, it will eventually generate a graph. Okay. So here's where it will generate a graph. That was after the graph had already closed. Okay, so yeah, so now you see how this graph, pops up in this window. You got to drag it, organize it. That's a pain. If I was instead using a Jupyter notebook, the graph would just pop up right here, and I wouldn't need to manage an extra window once that popped up. So lots of value in that. I actually might want to go back and rewrite that code to be in a Jupyter notebook just for that reason. But that's another thing. So the other thing is this is running in this terminal here. That's why I'm able to access it here. So if I do a Control-C, now I'm no longer running the web app. So if I try to do anything, the site cannot be reached. If I refresh it, site cannot be reached because I'm no longer running the site on my local PC. And then of course the beauty of this too is if I want to share my project with someone, I can just give them I can just make my PC or host this somewhere where it's publicly accessible, and all the files are centralized in one area, and you don't have to worry about people updating the same file, because there is only one file to update. Okay, I'm going to take a quick break. Unfortunately, I've got to do that quick, and then I will come back and read procedural programming. All right, I'll be back shortly. All right, procedural programming. If you've been around programming at all, you've probably heard terms like object-oriented programming, OOP, and functional programming. These are different hierarchical paradigms used to organize programs. One of the most basic paradigms, procedural programming, is an excellent place to start. Procedural programming is the issuing of instructions to a computer in an ordered sequence. As you can see in this example, there are 3 statements that are executed in order from the first line to the last. Each statement uses the state produced by the previous ones. In this case, the first statement assigns the value 3 to a variable named I. In the second statement, this variable's value is used to assign a value to a variable named j. And in the third statement, oh, why is it behaving unpredictably now? It's behaving unpredictably. I'm not sure what's going on there. Looks like my connection has got some problems. Yeah, looks like okay, there we go. Okay, so as you can see in this example, there are 3 statements that are executed in order from the first line to the last. Each statement uses the state produced by the previous one. In this case, the first statement assigns the value 3 to a variable named I. In the second statement, this variable's value is used to assign a value to a variable named j. And in the third statement, the values from both variables are added together. Don't worry about the details of these statements yet. Notice that they are executed in order and rely on the state created by the previous statements. Variables. A variable is a name that points to some value. In the previous example, the variables are I and j. Variables in Python can be assigned to new values. Python variables use dynamic typing. In practice, this means that they can be reassigned to values of different types or classes. So the big takeaway here is that in other programming languages, so if I do Python and then I do type the letter A, we have a class str, type the digit 1, we have a class int, type digit 1.0, we have a type float, and then there's all sorts of other types. Let's look at one more type like this, and that's a dictionary. So in other languages, if I say a equals this variable a, and we can see that the type of that variable is a string, I could not then go and say a equals 1 because I had already assigned that variable to a string type, so it could only be a string type variable. But that's not the case with Python. What's kind of nice about learning Python is you can just kind of ignore these limitations of older languages. They're often explained anyway as if you know it, which is kind of frustrating, to be honest, because like for me, like as a new programmer coming to the Python language, like a lot of what the beginner books have talked about is stuff that a new programmer wouldn't wouldn't understand as being like a breakthrough revolutionary thing in Python. So like the fact that Python uses dynamic typing really is not, I think, relevant at all. But I don't really knock the book for including it. I think it's important to introduce this concept, and they do it very concisely. Here is the same variable. Here the same variable is set to a string, a number, and a dictionary. Variables can be reassigned to values of any type because Python uses dynamic typing for variables. Basic math. Basic math operations such as addition, subtraction, multiplication, and division can all be performed using built-in math operators. Note that the // symbol is for integer division. The symbol ** creates an exponent, and the % is the modulo operator. Okay, and they're not going to explain what the modulo operator is, but it gives you the remainder. If you were to do long division and get a remainder, that is what you would get well, you wouldn't get that, but what you would get is, so like, let me demo that. So we'll do 10 modulo 2. So 10 is an even number, so it's 10 divided by 2 is going to be 5, which has a remainder of 0. But 10 cannot be divided by 3. Because if I did that, there would be a remainder of 1. 3 does go into 10 3 times for 9, but then you have one value left over, and that's what you get here. So it's 3 is not, 10 is not divisible by 3 because you have one modulo remainder left over if you attempt to do it. Alright, comments. Comments are text ignored by the Python interpreter. They are useful for documentation of code and can be mined by some services to provide standalone documentation. Single line comments are delineated by prepending with $. A single line comment can start at the beginning of a line or at any point thereafter. Everything after the $, is part of the comment until a new line break occurs. So you can see you can include it after legitimate code there. Once you have the line break, though, you're no longer commenting. Unless you use a multi-line comment. Multi-line comments are enclosed themselves in blocks beginning and ending with either 3 double quotes or 3 lower quotes. So we can see now we can have a new line there without it not being commented. Okay, so built-in functions. Functions are statements grouped as a unit. You can invoke a function by typing the function name, followed by parentheses. If the function takes arguments, those arguments appear within the parentheses. Python has many built-in functions. 2 of the most widely built-in functions are print and range. Print. The print function produces output that a user of a program can view. It is less relevant in interactive environments, but is a fundamental tool when writing Python scripts. In the previous example, the argument to the print function is written as output when the script runs. Print can be used to see the value of a variable or to give feedback as to the state of a program. Print generally outputs the standard output stream and is visible as program output in a shell. Okay, I'm getting really tired. Let's go to execution control, and we'll stop there. So the next function is the range function. Although range is a built-in function, it is technically not a function at all. It is a type representing a sequence of numbers. When calling the range constructor, an object representing a sequence of numbers is returned. Range objects count through a sequence of numbers. The range function takes up to 3 integer arguments. If only one argument appears, then the sequence is represented by the numbers from 0 up to, but not including that number. If a second argument appears, it represents the starting point rather than the default of starting from 0. The third argument can be used to specify the step distance, and it defaults to 0. Okay, and what they mean by step distance is when you iterate through, by how many steps do you iterate through. So if I were to do Python, and then example equals 1, 2, 3, 4, 5, 6, Okay, and then range. Wait, I'm confused. Oh, okay. So you gotta give it. So let's do a help on range. Okay, and I apologize here. I'm so tired. I'm barely hanging on here. But okay, let's just read this, and then I will be done. Range maintains a small memory footprint, even over extended sequences, as it only stores the start, stop, and step values. The range function can iterate through long sequences of numbers without performance constraints. So, okay, so this is where I'm going to bookmark it and stop for now. I'll see you in the next video where I start up with execution control.